Hi guys. Alright, I've been a little busy lately because at home in my parents' workshop I have one side which is just my stuff. Because I can't have all this stuff in my room, can I? It's a bit of a hazard and it's not too viable. First of all, this is my variac, fully built and complete, and it's running. Got a PowerPoint out here, old New Zealand one, nice, really reliable these ones, and some B&C or whatever, I don't even know what they're called, banana connectors. I need to put some stickers on these, make it look cool. The live earth neutral, variable 0 to 260 volts AC output. I'm planning to put some meters here because I'm currently using a multimeter clamp for the amps, volts, fume extractor. It's actually a fan, but people, idiots would know what I'm saying. Switched output, really satisfying. Love that. 9 amp 270 volt variac. I made a video on this before. Love that. It's working great. I'm off this cable here. Actually, I didn't show you this. I might show you the insides. There we go. Ain't light. Lovely, lovely. Emergency, well, not really emergency, just a safety switch. So when I open the door, it's going to cut out. So I don't get a nice zap. Anyway, right, pretty simple in here. Or very simple in here. I have got my output, input, this is not plugged in, and neutral. None of these. That's for 400 volts, center tap. Not going to be playing with that anytime soon because that's crazy. Only photonic induction can play with that. Oh, not really. He can do whatever he wants. Anyway, I've got some switchgear inside here. Input circuit breaker for the input and output. The reason why I had put an isolator too, that's just for pissing around really. The reason why I put two, because on a variac, the input current that you're reading and the output current that you're reading can be very, very different. And you don't want to fry your variac, so that's why you should put your protection on the output, because you may be pulling like 5 amps on the input, and then it's reading like 20 amps on the output. And for a little 9 amp variac, 20 amps is not going to be nice. It's double from what it's rated. What? More than double, actually. So yeah, 10 amp circuit breakers, so 10 amp on the input and 10 amp on the output. Even though this is 9 amps, I wasn't going to put a 6 amp because that'd just be tripping all the bloody time. So this can take probably 12 to 13 amps as overload, 9 amps constant. So yeah, that's why I put the 10 amps. So if I do keep held it at 13, they may trip over time. This is a double pole isolator. If I need to do some form of work off on 100 amp isolator, because it's what I found and what I had at the time. It's viable, it works, nothing unsafe. And the 10 amp circuit breakers, no RCD protection, because I didn't put it there. I might actually just put it in there, the RCD. But anyway, I should actually, but in the future I will be running this off an isolation transformer, and the isolation transformer is rated at 13 amps, so it should keep me safe for now. More wiring in there, earth connector there, it's floating around, kind of need to fix that. And there we go, it's the 3 connectors there for the outputs. Earth, live and neutral, you can see there nicely, and that's the hole that goes to the power point. Very simple. Close that. You heard that switch, and that's telling me that it's safe. Live in there. So that's your 0 to 260 volt output. Your connectors here, the banana connectors, neutral, earth and live. Need to put some stickers on here, and I might put some panel meters here in the near future. Yeah, lovely, lovely. Let's do some. Let me show you what an appliance reacts to a variac. Lovely. First of all, to turn a variac on, it needs to be plugged in. And I'm going to say this person, Boombox Deluxe, likes plugs and PowerPoints. He's going to see a nice one. In New Zealand, this is what we have. Nice. 32 amps. And that goes into there. It fits, but it fits. Alright, it's off. It goes right in there. No mucking about. I'm going to tell you about that wiring later. Right, I'll get this set up and I'll come back. Right, output, lamp, go into a socket. On, off, on, sounds really nice. Got voltage. Yes. Do I have power? 6 volts. Ah shit, something's wrong. Ah shit, something is wrong. Hold on. Right, problem solved. This is off. Just reading one stupid meter. It's off, off. First of all, you switch on, output. You slowly turn it up. Ooh, more. 73 volts. More. Ooh, bright, bright. And that's full, which is that. Oh, that's really bright. 257 volts. Let's go back to the 230. Lovely, lovely. We go all the way from 0. Let me put the meter up right next to you, right here. 45. Oh, it's slowly starting to warm up. 50 volts. 56, 61, 66, 74. It's actually not as bright. 92, 98, 104, 132. All the RS is shutting down again. There we go. 60, 170, 190. And that goes up, 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 up to 255. Cool. That's how I am set up down there. Here we go. Or, if I'm in a rush, I need to turn it off, I can just go, and that's off. Yep. Nice. Put down. But yeah, these lamps, or this lamp is designed for, oh, it doesn't even say. Oh well, I can just go 258. It's quite bright. I'll show you something else. Right, I've got you set up here. We're at 3 volts and the fan is connected onto the output. Let's go. No movement, no movement, no movement, no. Oh, it's at 49 volts. 50, 51, come on, gotta creep up. There we go. 53 volts. 64, 70, 85, 91, 95, 100. Gentle breeze. I might use this variac upstairs in my room. Variable fan. Ooh, variable speed, really nice. 192, 200 volts. There's a capacitor in there, I don't want to blow it up. I'll just stick to the 240. It's at 259. Yeah. Doesn't go too far harder, but yeah. Nice. You plug it into a US power outlet. Just fine tuning it. That's what it's going to be at US. Slowly. Then we go to New Zealand. Then I can just go to cut it off. Lovely. Right, off. So yeah, that's what you get for one of these. Anyway, talking about that power outlet, let's climb up and show you. There we go. This power point is designed for an oven. And that power point is there for because I created a power supply because this part of the workshop is now mine to use. So I have a dedicated part in a little workshop in my house. That's for me to use. 6mm cable going to that, so it's a really nice, got a lot of potential here to have some high current fun. So that socket and this lead here, 32 amp, that's a nice plug. Boombox Deluxe would love that, especially that nice and close. You might even be able to read the writing. No, you can't read that, but it's a different style plug. There's a regular one in New Zealand, one of these. And you look at that. And that lead, and that part of the lead goes into there, which is powering that. And that's going to power an isolation transformer, and that isolation transformer is going to power that. And there will be some other outputs on this too, as you can see. T1, that's for the transformer. AUX, which is just auxiliary, it's another contactor, and the main. Oh shit, that's come off. Anyway, almost finished. Just need to get some power into it. So that lead goes up on the joist, through that joist, onto the wood, and it goes down to a subboard. And as I said before, this is a basement and it has its own 32 amp supply right in here. There we go. And as you can see, I am sharing because I'm not tapping off any of these circuits because that's just a little silly. These are all 20s, that's not enough. I need 25. Let's just go a little closer, my arm's getting sore. So this is a main switch, sockets, RCD, lights, and me. Not really organized, but this is me. The other wiring's done by Sparky. It's me adding to it. That's a C25, and if I go, oh, that is well, let's switch it off, and that power point there is fed just in there. On, so I've got 25 amp service down there. More than enough to power the equipment, but enough to have fun. I could go, for the size of the cable, I could have gone for a 32 amp breaker because that can take a good 30 amps, but 25 is definitely enough, so I just chose 25 to be sensible, right in the middle, not too low, not too high. And also I got to remember that I'm sharing, so there could be other loads as well, so that's why I put 25, just to limit me, because I don't want to go too far and then trip the 32 amp in the main board, and then I'd be in trouble. So that's why I chose 25, because I'm sharing. Because it's not just me here, it's other people that can shut. Need to label that someday. Very easy. So yeah, that's my power supply. I thought that was quite sensible to put something like that there. The regular plug could fit into there, no problems. But I can't wait to be powering that off of this. It's going to be really fun. So have some good times there. It's neat enough, really, to be honest. That is not good. Well, yeah, that's not good. That's the only bit that I'm a bit disappointed on my side. But everything else, the clippings, should be okay. I'm not an electrician. Wish I was, to be honest. Once I finish school, that's one of my main goals. And go nice and close. So that's your earth, live, neutral. That's the connections back there. So nothing too shabby. Nothing's really going to interfere with that back there. So yeah, but if I was Rodelco, I would probably put a meter here. maybe not. Would be alright. Anyway, yeah, that's an update. That's what I'm really doing. Variacs, transformers, fun, and big power outlets. That's all I really have to say. That's all really I've got to offer for today. So, thanks for watching, and comment, tell me your thoughts, and get back to you. Have a good day.